Bismillahirrahmanirrahim. Measurement of hydrogen and CO2. pH is the hydrogen ion activity instead of concentration. pH is defined as the negative logarithm to the base 10 of hydrogen ion concentration. So pH of 7.4 equals 40 nanomole, to be written as 10 to the power of minus 7.4 mole per liter. pH falls by 0.1 for each 1 nanomole liter raise in hydrogen ion concentration. The curve here shows the relationship between the hydrogen ion concentration, the pH. In the middle of it, we find it almost linear. Measurement of hydrogen, we select what we call the ion selective electrode, a special glass electrode with a bulb. This bulb has the cations which change with hydrogen ion concentration. So whenever we dip this electrode in a media containing carbon dioxide, a potential develops and carbon dioxide is being administered according to the concentration. Of course, we have a buffer solution in this electrode to keep the pH constant. There is a membrane, of course, at its step to avoid contamination. We use a potassium chloride ion for stability. Of course, whenever we have silver chloride electrodes, we ought to use a solution which has a chloride. The silver chloride connection in the H electrode is then connected to a reference electrode, which also is made of silver chloride. A potential develops between the electrodes and it's measured. Of course, there is an automatic suction system to suck the sample. Of course, we must keep the sin in a proper temperature, 37. Otherwise, we must correct the defect whenever we use it in a hyperthermic situation. Of course, it's calibrated by 2-phosphate solution, and we ought to clean the membrane for any holes or the deposit of protein. Of course, there are special glass electrodes with different cations in their mesh for potassium, sodium, or calcium analysis. Measurement of pH of the CO2 is similar to what we had seen in this cell. We call it Severing house CO2 electrode. It's similar to the pH electrode, but it has a nylon mesh around the bulb of the glass electrode where it contains bicarb. Whenever the CO2 is entered, it's impregnated with the bicarb present in this mesh, and then this is the reaction ending by hydrogen and CO2. Of course, hydrogen is being taken to assist its concentration. This reaction, of course, can give a slight delay in the response, but it's very sensitive, up to 130 Pascal response time. And we find the result within 2 to 3 minutes. Of course, most probably we must subtract water vapor from any gases to get the proper concentration of carbon dioxide. Of course, there is a continuous continuous measurement of CO2 as that of oxygen, and we have also a transcutaneous carbon dioxide electrode. Infrared analyzer, as we can see, it is an instrument based on that. Whenever we have a molecule which has 2 or more different atoms, it can absorb infrared rays. So we use a wavelength of 4.28 micrometer. Of course, we ought not to forget that 1 calorie equals 4.14 joule. So we must correlate numbers to each other so that we will not forget. So we use this wavelength by special, of course, filters to transmit the light in the mixer where it contains the CO2, where I want to measure its concentration, and then it goes to a lens, and the lens goes to a detector at the final result. Of course, we use better is to use alternating current by a rotator disc. We call it chopper. This chopper, when it turns, it gives an alternating signal. It's less prone to drift, and it gives more accurate results. Glass was seen to absorb the infrared rays, so that we use different media. The one most probably used is called sapphire. This does not absorb, so the cell is made of this material. It was found that, of course, this infrared changes the distance between the molecules, so it increases its activity. And whenever there is nitrous oxide and they collide with each other, some of this energy is being taken by the nitrous oxide, giving more chance for the CO2 to absorb more infrared. So this gives fallacy. This change in the range of absorption by taking more infrared rays by nitrous oxide increases the brooding spectrum of absorption of nitrous oxide. This is why we call it brooding, collation broadening. You see, so this is a curve showing the wavelengths of absorption of carbon dioxide and nitrous oxide. So we can see that there is a range and a peak. We have two types of capnograms. The capnogram is a device to measure CO2. We have the side stream capnogram. You can see it's being carbon dioxide being transmitted by a narrow tube to the analyzer, where we have a flow of 150 milliliter per minute, speedy enough to decrease what we call the transient time. At the end, there is a moisture tube to collect the water vapor. And then we have what we call the mainstream. The mainstream decreases the time for the CO2 because the analyzer is immediately on the bulker. It is bulky. This is the drawback of it. It decreases the time for the carbon dioxide to reach the analyzer. Of course, whenever I decrease the chamber size, and I can get a transient time of around 400 milliseconds. Of course, nitrous oxide and other anesthetics are also used to be measured by such a system, infrared analyzer. Of course, we use infrared analyzer to absorb trace elements in the atmosphere, so it's very minimal. So we must have a wide or long channel of infrared rays. So we use, instead of a very long channel, angled mirrors to create this long channel to absorb parts per million. Of course, we can use gas chromatography and mass spectrometry and refractometry to also to measure CO2. Of course, we have what we call the chemical method. This chemical method is based from the absorption or the decrease in the volume or the pressure as long as CO2 is being absorbed by potassium hydroxide. This decrease can be justified to denote the CO2 concentration. Of course, metacresol purple is being used in the canister where the color of it is changed from purple to yellow by the absorption of CO2. Or we have a colorimetric also monitors used in the endotracheal connection to denote the presence of the tube in the trachea or in the esophagus. Gastric mucosal pH. It's just a gastric tube. We call it gastrotonometer. It has a balloon. This balloon is made of silicon, and we inject saline or air in it, and it equilibrates with the CO2 of the mucous membrane, where it is being decreased whenever there is a decrease in the splanchnic blood flow in shock patient. And this sample so we can by the Henderson-Hasselbalch equation denote the pH. As long as we can know the bicarb and we know the CO2 concentration, we can figure it out from the equation. Of course, pH below 7.32 indicates the hypoxemia. Of course, the repump taking the carbon dioxide every now and then from this balloon to continuous measuring the CO2. Of course, now we have double human caster. It recirculates and gives a response time in 5 minutes. So this is a hint about measurement of hydrogen and CO2. I hope that I didn't take more than the 15 minutes. Wassalamu alaikum wa rahmatullah wa barakatuh.